Hey guys, welcome to the demonstration of PID controller for a heating chamber. PID controller for heat chamber.
So here we will talk about how we design the system of the PID controller using the MyRIO. As you can see, this one is the heating chamber, this one is the MyRIO, which will control the temperature sensor which is inside the LCD, the switch which is this one, and the LEDs. Then to make the lamp work, this one is the lamp. We use the PID. We set it up as with the PID. Also for the fan, as you can see, we designed the PID so that there won't be any overshoot. So here, this one is our schematic basically. So as you can see, this one is the function for the lamp PID. This one is for the fan PID, which is in a loop, both of them. Also, this one is our output. The CD is now in a function but is inside the loop, because all of this is a for loop. And this one is our switch, and this one is our temperature. As you can see, we converted the signal from the temperature, and we convert it from we calibrate to degree centigrade temperature. As you can see here, this is the conversion. We also this one is the reading from the temperature, but we also set our temperature, the target which we are looking for, so we can control the fan or lamp. And later we will see how this will work.
Go.
Okay, so this part I already explained it. So now here, if you look, there is a switch. This block is just for the switch. Is reading the value from this switch, which is connected to the digital input. So when the switch is turned off, we will display on the display either this mode or enable mode. And also it will give a warning alert on the screen, which is here. Also here in the fan, we set up the PID, auto calibrate the signal, and the same for the lamp. Here in the display, we display the error temperature, which will occur only when the temperature will reach 55, as you can see here. 55 or more than 55. If this doesn't happen, it will display the normal temperature. Here, like for example, as you can see, there is the lamp. This one is the true condition, which everything will work. So for example, the LED one will work only if the switch will be the manual switch will be on, so the system is off. Then the switch 2 will work when the lamp is on, when the lamp is working. The switch 3 will work only when the fan is working, and the LED 4 will work only when the temperature reach more than 25 or 55, sorry.
Alright, now I'm gonna explain you the working and the output of this PID controller for the heat chamber. As you can see, my colleague has told you how we have designed the whole system. The PID for fan, lamp, the input stuff, the switch, the LCD, and the outputs. So basically we have placed the whole system into a while loop so that we can have a continuous output stuff. So now This is our input signal, that's the temperature sensor as we can see, and we have placed the temperature sensor inside the heating chamber. So since this temperature has to be calibrated into centigrades, this is the part where we are calibrating that into centigrades. And to design basically a PID controller, we need set signal as well as an error signal. So in order to find the error signal, we have subtracted our input, that's the desired signal, with the target temperature, and that's how we have designed the PID over here. So the lamp gain is multiplied with the error signal, and this error signal is added with our previous error, and that is multiplied with the integral gain, and this error signal is subtracted with the previous signal and multiplied with the derivative gain, and that's how the lamp PID is designed. In the same way we have designed the fan PID as well, and this is the part where we are controlling the system either manually or automatically. So coming towards the display stuff, we have displayed the using a LCD display, and we have shown everything. We are displaying the temperature, we are displaying the warning message, and we are displaying whether the system is disabled or enabled, and this is our output stuff, lamp, fan, LEDs, etc. So now let's go towards the working of it. Yeah, so when the signal is passed from the temperature, it gets calibrated, and then it is passed into the heat chamber, and PID stuff is performed on that, and you can see the results over here. If the condition is true, the PID will work, and if the condition is false, just an error message is flowing through the controller. Similarly to the fan as well, error message is just flowing into that. So now, as per the design scenario, if the user turns off the system by enabling this mechanical switch, the whole system will shut down and will get an error message that system got disabled. And to know whether the system got enabled or disabled, we have set it an LED which will clearly indicate that if the system is disabled, this will turn on and the whole system gets enabled. So it will work only if the condition is true, else if the condition is false, the rest of the thing will work. So if the set temperature is lower than, if the target temperature, if the desired temperature is lower than the set temperature, then the LED, then the lamp will turn on and it will take up the desired temperature to the set temperature. Similarly, if the desired temperature is much higher than that of the set temperature, then the fan will turn on and it will cool down the system. In a case of scenario, if the temperature rises more than 55 degree, the whole system will turn off and LED4 will, so the lamp will turn off and LED4 will turn on, and an error message is displayed that the temperature has gone beyond the normal temperature, so that the user can manually turn off the whole system. So let's just see how it works. So that's, now let's go to the control panel. We have placed this manual switch, the toggle switch, the warning alert. This is our graph which shows our PID stuff, that's a set temperature, etc, etc, etc. Now as you can see over here, the set temperature is 29 degrees Celsius and our desired temperature is quite similar to that. So as you can see over here, since it is a bit less, the lamp is glowing like in seconds. As the temperature is getting decreases, the lamp starts working, and if in case if the temperature falls below the set temperature, the lamp will turn on. I'll show. um, as you can see here, now I'm gonna change the temperature to 25, and let's see what will happen. Since the temperature has fallen to 25, the fan is on, as you can see over here. the fan is on and LED3 as well on. So that's now the system is getting cold and the temperature is falling down, as you can see. So in order to control the temperature, we have designed the fan PID, and these are the values of the gains what we have used, and basically we calculated these gains by trial and error method. So that's -4, -6 and -2. So now the temperature is gradually decreasing to 25. Once the temperature gets to 25, the fan will turn off and the temperature will be in a stable state. Right, the fan is working. Now if the temperature falls below the set temperature is higher than that of the desired temperature, you can see the lamp has turned on and LED2 is on, so that the chamber is now up to heating mode and it's heating the chamber. As you can see, the temperature is gradually raising over here. So when this temperature hits the set temperature, there will be the balance of desired and the target temperature, and the desired temperature will be equivalent. So as you can see here, the LED display, we are displaying the message. The current temperature value is 32.52 and the system is in enable mode because that's working. And now if the user turns off the system manually, the whole system gets shut down and a display message is appeared on this screen: system disabled. As you can see, disable mode. The system got disabled, whole thing is off, LED1 is on. Now let's go back to the enable mode and the system is working. Now let's go to the peak condition. If the temperature crosses 55, more than 55, the lamp should turn off and LED4 should turn on and we should get an error message on the screen.
How many, sorry, 16 by 16? And then do you have to do something else with it? Or do I leave it like that?
As you can see, the temperature has reached to 54, and if it crosses 55, you can see the lamp gets turned off.
Down here it can't move in the Y. So you restrict it and you go movement in X is 0 and movement in Y is 0. So you know you've got like U1, V1, U2, V2. You just U1 equals 0, U2, no, sorry, U1,
The temperature is reaching,
U3 and U.
and as you can see, there was an error message stating the system is turned off.
V4 and V5 equals 0.
So that's how the whole PID is working.
Oh, so, wait, so this is U1.
Thanks for watching this video. Give this video a thumbs up. Thank you.